Powell, shut up, boys! This is April 3rd, 2009, Friday night. That's right, we made a video Friday night. This is going to be the most exciting 40 minutes of your life, discovering the properties of the transition metals. Dr. Powell, this goes out to you and your family. The transition metals, dun dun dun. They have properties like metallic luster, starring number 21 SC, number 23 Valencium, All-American last year, and 30 zinc. Whoa! And now our host, Mr. Chickenhead. Our two teams, the D block. Yeah! And the F block, my grade in chemistry! Yeah! They had different amount of electrons in their outer shell, but that's okay. Keep going! Keep going!
Transition metals have similar properties like thermal conductivity and malleability due to their D and F block electrons. They also form complex ions, and I forgot the rest.
Oxides!
I said ions.
Oxides! Boom! Roasted.
Say they form oxides. Just say it.
They form oxides.
And now, introducing our host, Mr. Chicken! Yeah! Look at Mr. Chicken! And now we're going to focus on the first of the transition metals, which would be group pointed to Mr. Chicken. Yes, the first group, which goes from silentium, I believe, to zinc, which is probably wrong. Okay.
You said I could watch it. Let me watch it.
You said I could watch it.
You said I could watch it. This is so stupid.
What are you doing?
I don't know. Stop filming me. Oh, there's
Filming my dog.
What's going on over there?
I'll slice that camera up.
Alright, ready? We'll go. We'll do complex ions. The cations formed from transition metals are often complex ions. They are species where the transition metal ion is surrounded by a certain number of ligands. As you move left to right across the period, ionization energy increases. Alright, someone else talk.
Alex, go.
What am I saying?
Say they're reducing their...
These transition metals, represented by the chicken, with all his electrons, want to act as reducing agents and want to lose their electrons, like when the chicken loses the balls. And Alex puts them away so nicely. His mom told him that.
Are buried in the interior of these. In fact, the increase in nuclear charge causes radii. There's a significant increase in radius in going from the 3D to the 4D metals. The 4D and 5D are remarkably similar in size. This is called lanthanide contraction, which offsets the normal increase in size due to going from one principal quantum level to another. Thus, the 5D elements, instead of being larger than the 4D, are the same. A ligand is a neutral molecule or ion having a lone pair of electrons that can be used to form a bond or a metal. Damn it, I messed up. A ligand is a neutral molecule or ion having a lone electron pair that can be used to form a bond in a metal ion. This will represent our ligand. This top of the pine cone is where the lone pairs of electrons will be. Keep going.
Yeah.
This will represent our transition metal ion. Now when ligands come to this transition metal ion, they will form what is called a complex ion.
A complex ion.
They come together with the transition metal through coordinate covalent bonds.
Great.
A ligand that can form one bond into a metal ion is called a monodited ligand, or a unedited ligand, from root word meaning one tooth. Also, there are the bidited ligands, which is a ligand that can form two, not one but two bonds to the metal ion. So. Also, there are polyident ligands with more than one ion can form. A polyligand is a ligand that can form more than two bonds. So therefore, it's considered not really a big deal. Poly. There's also these things called chelating ligands, which I'm sure you guys all are very familiar with. Come from the Greek word for claw. And I don't know much about it, but have fun.